Hello, my name is Yash Sanjay Bahale. Subject name is WPT and my topic name is construction and working of large wind power plants. Construction and working of large wind power plants. Here are the subtopics: wind turbine terminologies, major parts and function of wind power plant, rotation principle, different types of sensors and different types of actuators. So first, wind turbine terminologies. Cut-in wind speed. This is the minimum wind speed at which the turbine blades overcome friction and begin to rotate. Second is cut-out wind speed. This is the speed at which the turbine blades are brought to rest over avoid damage from high wind. And third is power curve. This is the steady power delivered by the turbine as a function of steady wind speed between the cut-in and cut-out wind speed. Survival speed. Wind power increases with the cube of wind speed turbine have to build to survive much higher wind load. Survival wind speed is the maximum wind speed of the wind above which wind turbines will be damaged and the speed up to which turbines are designed to withstand safety. Survival wind speed, commercial wind speed is the range up to 40 to 72. Rated wind speed and rated output power. The rated wind speed and the rated output power are indication of relative value of wind speed required for the wind turbine to produce large amount of power with safe limits without damaging of turbine. It is the maximum capacity of wind power plant to produce power when the wind is in ideal range. Nominal wind speed and nominal power output. This is the lowest speed at which the wind turbine reaches its nominal power output. Threshold wind speed. The cut-in and cut-out speed are operating in this range. It ensures that the available energy is above the minimum threshold and the structural health is maintained. The turbine designed above the rated wind speed is not effective. Wind power curve. Power curve is a powerful tool to estimate the power extraction process. Here is a layout of wind turbine. Here is a arrangement of vertical and horizontal axis wind turbine. Here is the uh, inside the nacelle what are the components: hub, pitch, etc. Rotor blades of wind turbine. Blades from mechanical system of wind turbine which convert wind energy into usable mechanical energy. Wind energy rotates the blade of turbine. This rotation transfers its mechanical energy to the shaft. Now the hub of wind turbine. Hub is a component that connects the blade to the main shaft and ultimately to the rest of the drive train. Nacelle. The nacelle is a big box mounted on a tower in the house. All components of a wind turbine. Gearbox. Gearbox increases the shaft speed of and matches with the generator speed. Generator is an electrical device that converts mechanical energy received from wind turbine shaft into electrical energy. Permanent magnet synchronous generator means PMSG or induction generator are used. In some wind power plants, DC generator with inverter system is used. Power electronic converters. As wind energy is variable, so electrical energy from generator is not constant and it becomes necessary to keep constant output voltage to transfer it to grid. Converters also enable transfer to active and reactive power flow. Turbine controller. It is a computer program PLC that controls the entire turbine and offers self-diagnostic in the case of any error in the turbine. Here is a picture again. Rotation principle. There are two primary aerodynamic forces at work in wind turbine rotation, which are lift, which acts perpendicular to the direction of wind, and drag, which acts parallel to the direction of wind flow. Sensors used in wind turbine are accelerometer, temperature sensor, etc. First is anemometer. It is a small device with three blades and it is used to measure speed of wind. Wind vane. A wind vane is used to determine the direction of wind and with the blade with and with the blade, the electronic controller can determine more appropriate direction of the blade to have maximum possible energy. Vibration sensor, it is very simple safety sensor. Eddy current sensor, eddy current sensors measure to the lubricant gap of the shaft to ensure it always covered by a thin film. Oil is applied under pressure. It also measures torque, deflection of clutch, disc, etc. Displacement sensor. Variety of displacement sensors are used to monitor structural integrity. Accelerometer. It is used in wind turbine to detect and monitor vibration within main yaw and slow bearing and shaft. It monitors changes in wind speed. Wind sensor. Sensors are mounted on the top of the nacelle and either mechanical or ultrasonic. It measures the distance of the object. Temperature sensor. It is used in locations where temperature increases and indication given for overheating of components. Here are the features of horizontal axis wind turbine. It is a 7 years vertical axis wind turbine. This is Darius vertical axis wind turbine. This is H-blade vertical axis wind turbine. This is Gloro vertical axis wind turbine. Actuators, different types of actuators. Actuators plays a crucial role in wind turbine. Actuators are used in wind turbine as a motor or an energy source to move the control and certain components. First, this is hydraulic actuator and this is pitch actuator. Actuator offers a highly efficient turbine operation, lower production cost and minimize maintenance cost. Wind turbine has two axis control, yaw and pitch control, and second is braking system. First is yaw control. It keeps the turbine facing to wind, and pitch control. It is continuously adjust the angle of blade to ensure as high and constant power output as possible. Pitch control can be done in two ways: electrically and hydraulically. Electrically pitch control. In this system, motor with an attached brake is coupled to the pitch control mechanism through gearbox. And second is hydraulic pitch actuator. In this system, blade angle is controlled by one or more hydraulic cylinder placed in the hub of the turbine. Hydraulic system has more power density than electric. This system is safe and reliable with a rapid response. Advantage of this system is these are widely used in large wind power plant as it result optimizing performance, maximum damping, low wear, less maintenance, etc. Hydraulic pitch system. It contains pitch actuator, pitch accumulator, control panel, hydraulic pitch power pack, hydraulic pitch control system, control pitch angle by feedback blade positioning system. Yaw mechanism. The yaw drive is an important component of the wind turbine system. Yaw mechanism is used to turn the wind turbine rotor to face the wind. Yaw control is an excellent way of controlling the power input. This is the picture of yaw system. Wind power cables and untwisting. Wind power generation cables connect the primary generator motor in the turbine nacelle with the transformer and supply that electricity produced to the power grid. Highly flexible cables are required so that they will sustain without damage even if the generators rotate thousands of cycles. When the turbine cable needs to untwisting, control system receives mechanical or telecommunication signal from the mechanical switch or by twist sensing component and pulley wheel. Braking mechanism in a wind turbine. Braking systems is one of the most important safety devices. The braking system of the wind turbine ensures that it is automatically stops when it detects that one of the critical component does not work properly. A wind turbine system compares variety of sensors to detect an incident from overheating or of generator to protect against high wind speed. So there are two types of brakes used in wind turbine. First is aerodynamic braking system and second is mechanical braking system. First is aerodynamic brakes. Active pitch control. Blade pitching provides a highly efficient means of aerodynamic braking. In large wind turbine, pitch mechanism enables the rotation of blades on the longitudinal axis and it can change the angle of attack of blade with respect to wind. by which the aerodynamic characteristic of blade can be adjusted. It protects the turbine and also improves conveyor efficiency. The pitch mechanism can be either hydraulic or electric. Mechanical brakes. Mechanical brakes consist of steel disc brake accented one of by move brake capillaries. It can be situated on the rotor shaft or low speed shaft or on between the gearbox and the generator for high speed shaft. This is the picture of mechanical brake. Yaw brakes. It is an effective means of smoothly controlling and wind turbine nacelle, and it operates upwind. There, they are usually installed as a drag brakes and operate by controlling back pressure and provide braking torque. Thank you.